Okay, welcome back. We are actually going to move on to our Unit 3. So I want you to, in your notebooks, make a cover page like we normally do. And we're going to label it Unit 3 Plate Tectonics. Excuse me. Now, before we get started, I do want to tell you that I'm going to do things a little bit differently. This unit is hard to do from home in terms of we can cover the content. It's just a lot of hands-on stuff that we can't do. So in an effort to fit this in by the end of this school year, I'm going to shuffle things around a little bit and change the way we do it, kind of. But we're still going to cover everything. It just might not be in the order that the book gives it to you. Although we will use the book, and if you look on Classroom, I changed and added the Plate Tectonics book to the top of the classwork feed also. So it's there. Okay, so instead of doing activities, I'm going to break this down by lessons. So our first lesson, so up in your title page, you can call it lesson number 1, Layers of the Earth. Okay, so that's going to be our title. Our challenge question is going to be, what is beneath the Earth's surface? Okay, so we're going to have some key vocabulary. We're going to talk about the Earth's crust, the mantle, the outer core, the inner core, and something called the lithosphere. Now, for the first 4, instead of having you do a normal definition, I'm going to have you copy this chart. And I just copied and pasted it from the book. And in class, we normally did this a different way. But for the sake of time, I'm going to have you write the different characteristics of each layer. So you're going to see that the crust is our top layer. It is approximately 40 kilometers deep at its deepest. It is solid, and it is made up of many different kinds of rocks. All the rocks that you can think of that you have seen in rock kits and in your yard and at museums, all part of the crust, okay? The temperature range for the crust at its deepest level can be 700 degrees Celsius. Keep in mind that water boils at 100 degrees Celsius. So that's pretty hot at its strongest, deepest depth, okay? Below the crust is the mantle. So the mantle goes down approximately 2,800 kilometers. The top part of the mantle is solid. The bottom part is liquid. That is where our magma is. So we're going to talk about magma and lava. The mantle is made up of iron, magnesium, and silicon compounds. And it can range all the way up to 2,800 degrees Celsius. So pretty hot. I mean, we're talking about melted rock. And then even beneath the magma, it's even hotter. Below the mantle is the outer core. It reaches down to 5,200 kilometers. It is a liquid layer. And we're going to talk about how we know that it's liquid in a little bit. It is liquid metal. It's made of iron and nickel. And its temperature range is upwards to 5,200 degrees Celsius. Okay. Our inner core takes us to the center of the Earth. So if you were to find the center point of the Earth from the top of the crust to the center, you were looking at a depth of 6,400 kilometers. It is a solid core and it is metal. It is that iron and nickel. And the temperature in the core is over 6,000 degrees Celsius. That is hotter than the surface of the sun. So our inner core is very, very warm. And it is what makes our planet hospitable to life and why we are able to live on our planet. The 5th definition, that lithosphere, and we'll get into this a little bit today, but the lithosphere includes all of the crust in the very top part of the mantle. So it's kind of like an extra definition of a layer, and we're going to get to that eventually. So I'll use that term a lot, lithosphere. Okay, so pause if you need to, but make sure you have this chart recorded and the definition of lithosphere before you move on. Okay? All right. So I took this from the reading in the book, and I'm just going to read it to you. So, inside the Earth. Early evidence about the inside of the Earth came from volcanic eruptions. In the last 100 years, scientists have been learning more about the Earth using technology and new methods for gathering evidence. For example, scientists have learned a lot from studying earthquakes. Earthquake waves move through different materials in different ways and at different speeds. In general, these waves move faster through more dense solids than they do through less dense solids. The waves move the slowest through liquids. Scientists, such as the one shown below, measure the waves from a single earthquake at different places on the Earth's surface. By analyzing and comparing the data from many earthquakes, they've been able to determine the state, solid, liquid, or gas, of the materials inside the Earth. Scientists now know that the rocks on the Earth's surface are only a tiny fraction of what makes up the planet. Think of the Earth as an egg. The thickness of the eggshell would represent the thickness of all the rocks at the surface, so the crust. Beneath an eggshell, there is an egg white and an egg yolk. What is beneath the rocks at the surface of the Earth? Research indicates that the Earth has 3 layers, a crust, a mantle, and a core. The core is made up of both a solid and a liquid layer, which are usually described separately as the outer core and the inner core. Information about each of these layers is summarized in the table on the next page. Guys, that's the table I had you copy already. Okay, so you already have that information. The magma that erupts from volcanoes often comes from the mantle. Magma rising from the mantle can collect in underground chambers in the Earth's crust, building up pressure before exploding toward the surface. The mantle is almost 3,000 kilometers thick, which is about the same as the distance from New York City to Denver, Colorado. The land from New York to Colorado is not always the same, and neither are all the parts of the mantle. The uppermost part of the mantle is more solid than the lower part. Because the upper mantle and the crust are both solid, geologists have a name for the combination of these 2 layers, the lithosphere. Litho means stone in Greek, and the lithosphere refers to the first 100 kilometers below the Earth's surface. Okay. And I hate to read to you, but that's what we would have done in class. I would have read it to you. So here's what we would have done. And this whole activity is you creating this drawing. We would have filled this out together, that the distance to the center of the Earth is 6,400 kilometers. We would have measured with a ruler this distance. And when I measured it, it is 8 centimeters on a full-size sheet of paper. So I had to create a scale. So I would have taken 8 centimeters, okay, or 6,400 kilometers, and divided it by 8 centimeters. And what that would have meant was for every 1 centimeter on this line, that would represent 800 kilometers, okay? So that this is a scale drawing that you would have created. So I used the numbers in our chart, and I added lithosphere here. And I created their depth to scale on this drawing. And I just measured it over, and I connected my lines, and I colored it so it looked better, and I scanned it in for you. This is one of those things that take us a full 80 minutes to do in class. And if I knew you all had a printer at home, I would have you print that paper and do it. But unfortunately, I know some of you don't have access to a printer. So I'm just going to show you what it looked like. The key point that I want you to notice here is, do you see how I drew the crust in green? That green is too thick, okay? So our crust is 0.05 centimeters. That means if I go to the 0 and the first line on a ruler, the very first one, and divided that teeny tiny space up into 10, I would go over to the 5th part, and that would be 0.05 centimeters. So the thickness of that colored pencil is thicker than 0.05. So I have a note here that the crust is not drawn to scale. It's actually smaller than that. Same thing with the lithosphere. The lithosphere would measure 0.125. and you could probably get pretty close with a ruler, but it's not going to be accurate because our crust is not accurate. So I drew it a little bit bigger just so you could see the difference. But note, it's not drawn to scale either. So you have this solid outer part, the crust and the top of the mantle. Here's where your magma is that feeds the volcanoes. It's in the center of this mantle. And your mantle is your thickest layer of the earth. Okay? So you might be saying to yourself, okay, Mrs. McNeil, well, how do we even know that? How do we know what the earth, what the layers are even are? Well, like they said in the introduction, we use data from earthquakes and volcanoes, and I'm going to show you a video in a minute so that you can, they're going to show it to you in a video and how we measure those earthquakes. Okay? And then that lithosphere that we were talking about is actually broken up into these chunks, and we're going to get to that tomorrow. Okay. Students always ask every year when we talk about depths and how deep the layers are, how far we have gone. So the deepest hole that has ever been drilled on Earth has been drilled by the Russians. So in 1970, they started drilling this hole, and they drill it in a space called the Kola Peninsula. It's near Scandinavia. And they have drilled the largest hole that anyone has drilled on land. They had to stop drilling in 1992 because it got too hot, and the drill bit is metal, and it started to melt and warp, and it's really hard to work at that depth. But that being said, guys, that is still in the crust. So we have not been able to get to the mantle. It's too hot. We can't get there. So when you're drawing to scale up here, we can't even get through the green part. Okay, so just to give you an idea of how big the Earth actually is, that crust is so tiny compared to the rest of the planet, and we can't get through it. Okay, so I know when you were little, you always talk about digging to China, or what would happen if I got to the core. We can't even get to the mantle yet. Okay, now because the ocean crust is a little bit thinner, we have drilled a little bit deeper in the ocean. And if you saw the movie Deepwater Horizon, the Deepwater Horizon oil rig, I think, still holds the record for the deepest hole in the ocean that they have drilled. Okay. But I don't know the actual depth. You'd have to look that one up. But on land, the Russians still have it. Okay. All right. So what I want you to do is to go ahead and go watch the Talk Nerdy to Me video. It's called Earth's Interior Isn't Quite What We Thought. Give that a watch. And then I want you to do the lesson 1 exit ticket. Okay? And you will find that in the classwork feed. Okay? That's it for today, you guys. I'll see you tomorrow. We'll talk about those lithospheric plates. Have a great day.